Okay, so what about converse of this? Just 1 minute. Just 1 minute. Conversely, so we have seen that if f is analytic, then it satisfies Cauchy-Riemann equation. Let G be a region that is open connected set and G to C be a function with u plus iv has continuous partial derivatives. Furthermore, del u, del x, del v, del y, del u, del y minus del v, del x. So these two are conditions: continuous partial derivatives and these are conditions. Okay, that means CR, Cauchy-Riemann equation, we claim that f is analytic. On G, let Z belongs to Z and mod H less than delta, where B Z delta subset of G, because G is open set, so there exists delta greater than 0 such that it B Z delta subset of G. H equals to S plus IT. Limit H tends to 0. F Z plus H minus Fz by H equals to, what is that? F equals to U plus IV. So I calculate it. Limit S plus IT tends to 0, X plus S, Y plus T minus UXY plus IV X plus S, Y plus T minus VXY by S plus IT. That can be that can be written as 0. So UX plus S, Y plus I, Y plus T minus U X comma Y plus T plus U X Y plus T. I just add them. Same V by S plus IT. Now this term U X plus S, Y plus T minus U X Y plus T equals to del U del X X plus S1. I fix Y plus T, then it is a function of X. By mean value theorem we can write it as, and T1 T sum by the mean value theorem. Okay, this now phi st this sum function U X plus s y plus t minus u x y um, if I add them, uh, what happened? Minus del u del x ys plus del u del y x y t. Now if I add them, then what is the value? It is actual mm, del u del x plus s1 plus t minus del u del x y. I write phi s t by s plus I t. What is that? S by s plus I t. Just calculation. Plus t by del u del y x y plus t1 minus del u xy. Okay, now as this equals to s plus it, t less equals to s plus it, s1 so what is the limit s plus it tends to 0? Phi st by modulus, I just take modulus s plus t. What is this? So just take modulus and now use that partial derivatives are continuous. Okay, so it is 0 as so you can take this limit. So what is partial derivative are continuous, so limit s plus it tends to 0, that means limit s tends to 0, so this is 0 and this is also 0 and these are less than 1. Take modulus, then apply triangle inequality and you can see. So therefore u x plus s y plus t minus u x y, I can write it as del u del x x y s plus del u del y x y t plus phi s t where limit s plus it phi st it 0, that tends to 0. Okay, similarly we can write Vx plus s y plus t minus Vxy can be written as del V del x xys plus del V del y xyt plus psi st, where psi st psi modulo 0 means these are individual 0. I can write it as 0 psi st so now I want to go this line. This line is star. So from star we can say just put the value. Star and using CR equations we get just I'm using I think I of that. Thus where h equals to s plus it, I just recalling it, limit h tends to 0 xy. Okay, therefore f is analytic. So I am using here mean value theorem. So connectedness is important, number one, and I have also used the continuous partial derivative here. This line, this is 0. Why this is 0? If it is not continuous, then I cannot say. So for converse of partial converse of Cauchy-Riemann, we use connectedness, and for mean value theorem and continuous partial derivative. Okay, these two criteria, it is very important. So I can write it as a theorem. So what we have done, let u and a be real valued function defined a region and suppose that u and v have continuous partial derivative, then F C defined by Fz equals to Uz I is analytic we satisfy the equation del u del x equals to del v del y and del u del y equals to minus del v del x. Okay, so this is your theorem. Okay, if you have any question, please ask me. Remark: suppose C G region and have second partial derivatives, then from the CR Cauchy-Riemann equations we get since the partial derivative continuous, we have these two are you can change your order, del x del y equals to del y del x partial. Any function with continuous second derivative satisfying is said to be harmonic. Hence, U is harmonic. Similarly, V is harmonic. So, if F is analytic, then U V R and it is given that U V have second partial derivative continuous, then U V are a harmonic. Okay. Now, is the converse true? Think it. Suppose G is a region and V is analytic. So, and Fz equals to uz plus I Vz for all z belongs to G. Okay. Just 1 minute. Just one. Give me 1 minute. Okay, so we just list down what is this by chain rule: del u, del z, del u, del x, del x, del z, where z equals to x plus iy, z bar equals to x minus iy. This imply your del x, del z is half, del x, del z bar is half, and del y 1 by 2y, just I put these values: del y z equals to half, del u similarly, del u half, just to note down what half del v by Cauchy-Riemann equation just right. Del y again, so what can you say? Del v del z, you can say z bar. Now f equals to just apply chain rule. What is this? Now put values. And equals to 0 by this. So f is analytic on G implies 0. So I can write this is like that. G is the region if and only if f has continuous partial derivatives and uh, satisfy CR equation. This implies this. Now question is the converse is true? What can you say about this part? Suppose f is a function on a region G to C. Now del f del z bar is 0. What can you say about f? Is it analytic? Just 1 minute. Okay. Next we go to the theorem. This is application of Cauchy-Riemann equation theorem. Suppose that f is analytic where G is a region. Some book says that domain. We have if 0 in G, then f is constant. If one of f real f, imaginary f, argument f is constant in G, then f is constant. Equivalently, we say that if fg lies in either circle or a vertical line, or horizontal line, or any line with constant slope, slope, then f is constant. So mod f is constant means fg lies in circle. So similarly, real f constant, imaginary f constant, argument f constant. That means it lies on uh, vertical line or horizontal line or any line with constant slope. Okay, proof. So we have f dash z equals to del u del x plus I del v del x by the Cauchy-Riemann by here, I think, not here. Where is the starting? Yes, here, that is that line. F dash z equals to del v del x minus I del v del. Now you can replace del v del x by del u del x and del u del y by minus del v del x. So I can write it as this. Okay. So it is given 0. This implies del, because both are real valued, 0. So, since G is connected by mean value theorem, we can say that connectedness is needed here. Okay, so sorry, not u0 v0, I want to say that derivative of u is 0, so partial derivatives are 0, so you can say that u is constant and v is constant. So this implies f equals to u plus g. Again, suppose if r equals to 0, then simply f equals to 0. Suppose r not equals to 0. Now 2u del u del x plus 2v del x 0, this implies u del v y plus v by CR equation. This is 1. Again 2u del u del y plus 2v equals to 0 minus u del v del x plus v del v del y 0. Number 2, from 1 and 2 we get u square plus v square that is r square. Now r not equals to 0. Similarly, so f is constant. Since u is constant, rest are similar. Okay, so this is one interesting theorem or immediate application of Cauchy-Riemann. So one remark: suppose f and g are analytic on a region G and f dash z G dash z all z belongs to G, then if G is constant, that is C. Okay, notation: let G be a region and H G is the set of holomorphic or analytic function of all G. Note that if G belongs to G imply F plus minus G belongs to F defined as for all belongs to G. And HZ1 for all Z belongs to G is the identity. Then H belongs to H. Thus H G plus dot is a commutative ring with identity. Is it integral domain? Is it integral domain? Is it field? Okay. Problem. Just another application. Let and define G star Z such that Z bar to G. This look like sigma, but not, it is sigma. This is Z bar belongs to G. If C is analytic, prove that F star G star to C defined by F star Z F Z bar is also analytic. Z equals to x plus iy is in your chart. F x plus iy equals to ux plus y. So f star x plus iy let u1 equals to ux plus iy x minus iy and v1 minus v x minus iy, then f star v1 note that partial derivatives of u1 and v1 by this relation, partial derivatives of u1 and v1 exist and they are continuous. And by the formula del u1 del x equals to del x del y del v1 del x so partial derivative continuous given f is analytic. This implies it satisfies Cauchy-Riemann equation del u del x equals to del v del y, and this implies del y del u1 del x equals to del v1 del y minus del u1 del y equals to this implies f star has continuous partial derivative and satisfy CR Cauchy-Riemann equation. Hence, F star is analytic on G star. One note that G is region open and connected. Imply G star is also open and connected. So now we can use the theorem. So G star is also region. Prove it. Okay, homework. So if you have any question, please ask me. Otherwise today I will stop here. Okay, no question.